All right, pre-calc. So the next lesson, or the first lesson in our next unit, is actually going to be the first two sections of Chapter 1. All going to be about functions and their graphs, and then important characteristics that they have. So by the end of the lesson, you'll be able to identify a graph's domain and range, the x and y intercepts, and then also a value for the function. So to start with some key terms, x-intercepts, most of this hopefully is a review for you. We know it's the point where it crosses the x-axis. They're also going to be referred to as the zeros, solutions, or even you could say roots of the function. Y-intercept is going to be the point where it crosses the y-axis. A lot of times this will also be called as the initial value of the function, in particular when we talk about a problem situation, so like a word problem. Domain we've talked about is going to be your input or your x values, and remember you need to worry about your restrictions. Can't divide by 0, can't take an even index radical of a negative number. And then finally range is also not a new one, but it's going to be our output or our y values. Hey, moving on then, three functions that we're going to need to remember what their graphs look like. So linear, again these are nothing new for us. Linear is just going to be a straight line. This one has negative slope. Rising left to right would have positive slope, and you can even add in there your equation for a linear function using function notation. F of x equals mx plus b. If we talk about a quadratic, then that is also a parabola, and function notation for a parabola, f of x equals, and this is going to give us an x squared plus bx plus c. So parabola, that one opens up, so a is positive. We'll get more into that later. Cubic then finally is going to kind of have a curve in it somewhere, and that is going to be of the form ax cubed, and then we could have a bx squared plus cx plus d. Usually this is not the form that we're necessarily going to see it in, but what we need to recognize is that our highest degree here is a cube, which makes it a cubic, and it will have some sort of curve like this. Okay, so if we have a function, then again, not a new definition, but it's going to be an equation in which our domain value corresponds, and this is the important part, exactly one value in the range. So no domain value can have two values in the range. One range value, we can get the same range value from two domains, but one domain has to have a single range value. And then vertical line test is something we can apply to decide if it is in fact a function. So if we draw a vertical line anywhere in the graph and it hits it more than once, it would not be a function. So you'd have to think about all places in the graph. If it hits it twice, it's not a function. So evaluating a function f of 2 just means that we are going to plug in a value or an expression. Okay, on this first one we're just going to plug in 2. It's fairly simple, so we'd have 2 squared plus 3 times 2, so everywhere I have an x, I'm replacing it with 2, and then plus 5. So I get 4 plus 6 plus 5, and that would give me 15. And now it gets a little more complicated when we change it from a value to an expression. So here we're going to have a negative x squared plus 3 times a negative x plus 5. And then remember, anytime we square something, the negative sign disappears. So we could actually just call this x squared. And we're going to change our sign. 3 times negative x is like minus 3x plus 5. So f of negative x would equal x squared minus 3x plus 5. Okay, and then the last one, this is probably the one that's the most complicated. So f of x plus 3 means that everywhere we see an x again, so in both places up here in our original function, we need to replace with an x plus 3. So we're going to have x plus 3 squared plus 3 times x plus 3 plus 5. So you'll see everywhere there was an x, I just changed to an x plus 3. Now we need to FOIL and simplify. So I'm going to FOIL this x plus 3 squared. Remember, that's not just x squared plus 9 squared. It's actually going to give us x squared plus 6x plus 9. Distribute my 3, so 3x plus 9, and I still have my plus 5. Finally, last step on this one, I'm going to combine my like terms. So I have an x squared plus combine my x's, I get 9x plus combine all my constants, so 18, 23. So f of x plus 3 would give us that whole thing. And now for the biggest part of this lesson is identifying key characteristics from functions in a graph. And this is really what we're going to focus on next class session. So if we talk about our domain, remember that means our x values. So we want to read our graph from left to right, worrying only about the x values. So not about how high we go or how low we go, only from left to right. And because this arrow is going up, it's also going to the left. That tells me my domain is going to start at negative infinity. Likewise, this arrow is going all to the right forever. It tells me my domain is actually all real values, negative infinity to positive infinity. If we talk about range, now this is our y values. So you want to be careful here. You want to read it bottom to top. We want to start with our lowest values. So if I look at my graph, I'm worried about my y values here. Looking at my graph, I see that at my lowest point here, if I take it over to my y-axis, I'm at negative 4. So in this one, I'm actually going to include a bracket because it actually includes negative 4. And then I could see that my arrows are going up forever, so that tells me I'm going to positive infinity. And on this one, I put a parenthesis. So infinities are always parentheses. If we don't include the value, we want a parenthesis. If we do include the value, we want a bracket. So it's like last chapter, P9, we talked about this for a little bit. And then our x-intercept. So you can have more than one. You see we have one at negative 3. So I've got an x-intercept at negative 3, 0. I've got one right here and also right here. So I've got them at negative 3, 0, 2, 0, and then also at 5, 0. Okay, finally my y-intercepts then. In this case, there's only one y-intercept. It's going to be right here where we cross the y-axis. So remember, x goes first, which is 0, and then negative 2 for the y-intercepts. A last little piece then, identifying values from a graph. If I look at f of 4, so that means I'm going to, where x is 4, and I'm going to go down and look at my graph and then take it over and say, okay, I'm at negative 1. So f of 4 equals negative 1. Okay, the other way we could do this then is to take those lines and change them, where if I tell you that f of x equals negative 4, this really means that you're given a y value. So y is negative 4. So we want to look, where is y negative 4? Well, we go to negative 4 and then out to our graph. And then we're going to look up at our x values, and we're going to say that is when x is negative 2. Okay, so two ways we could do that then. If you're given the x, you find the y value. You're given the y, you find the x value. And that's it. So tomorrow, or next session, next time we see each other, we are going to really focus on graphs and finding their domain and their range, and then their x and y intercepts, and then values like we really did on that last problem. Okay, we'll focus probably on the next day on evaluating functions for given inputs, like the x plus 3, the f of x plus 3 thing we looked at. All right, we'll see you next time.